This is Mastering Mathematics with your teacher, Karen Weston.
Hello, welcome to Mastering in Mathematics, third in the series produced by the Ministry of Education in conjunction with ABS Television. As I told you before, we're going to make everybody in Antigua and around the world maths wizard. Today, we're going to introduce a new topic, and that is sets. At the end of this session, I will tell you, you will know how to, 1, define a set. 2, the elements. What is the elements? And also the number, how to find the number of elements in a set. And 3, what is a finite set? And an infinite set. We will also know what is the null or empty set. And of course, we want to know what is the universal set. Then after that, as long as we start talking about sets, we know we're going to be having them grouped. And for that, we're going to be defining for you subsets. The number, how do we find the number of subsets in a set? What do we mean when we start talking about equal sets? And where we have equal sets, we are going to be talking about equivalent sets. What do we mean when we start talking about equivalent sets? And we can call it a one-to-one correspondence. Again, as long as we're dealing with set, for everything, we try to make certain that there is visuality in what we have to present. And so we start introducing diagrams. In sets, most of our diagrams, the main word you'll be hearing is a Venn diagram. And once we start getting into diagrams, you know we're going to have compartmentalization so that there will be different things. And so we start getting in some new words where we'll be talking about the complement, okay? The complement of a set. And from the complement, we can look to, and you know, as long as we have sets and we have more than one, we have 2, we have 3 and more, we're going to, something has to happen, that there will be intersection. So we'll be looking at the intersection of sets. And of course, where we have our intersection, we can also have disjoint sets, okay? And then we want to know the number of elements in two sets. The number of elements in two sets. Okay, so this is a full complement of what the content of this lesson will be all about. We'll be introducing for you sets. And just as we said before in the last lesson, where we talk about having its own vocabulary and that there are new words and it will be specific to a particular topic, this is the same thing that's happening here now. We're introducing the topic sets. Our big overall topic would be sets. Very nice topic that comes in our exams, and nobody should be afraid of this topic at all because it is really very easy too, okay? But before we start anything, you must know your definitions for the things that they're going to be asking you. And that is why before we start anything, we look and we see these are the things. We have to know what do we mean when we're talking about a set. So we have to define the set. There will be things where we'll be looking at elements for a set. When that word is used, what does it mean? They can be using the word finite set, or it can be an infinite set. Then you will see these terms, null or empty set. You talk about the universal set, subsets, the number of elements in a set. Then we can be talking about equal sets, equivalent sets, Venn diagram, the complement of a set, the intersection of sets, disjoint sets, the number of elements in two sets. So our first order of business for today is to define a set. And for that, we would just be saying all items of the same kind, we refer to them as a set. So we say a set is a collection of items, usually of the same kind. A set, it's a collection of items usually of the same kind. And I'm sure if I had you sitting in front of me and I had to ask you, have you ever heard that word set mentioned anywhere in your mathematics class? What is it we talk about specifically when we start talking about sets? And yes, I can see the heads nodding visually, yes, because you know that one of the things that you're asking your mother for, and especially our fifth formers, you must have a geometry set. That is right. So that is one of the first things that we talk about, that we must have our geometry set. For those of you playing sports, you know you have your set of rackets, you have your set of tennis balls, you have your set of everything that goes along with what you're going to be using, okay? So you would have had all these things now, so just to give myself some more room on the board, I will now erase them because you had enough time to write them all down, so you know that at the end of this session, we're going to be asking you to know these things, okay?
Whenever possible, draw a diagram. Even though you may be able to visualize the situation mentally, a hand-drawn diagram will allow you to label the picture, to add auxiliary lines, and to view the situation from different perspectives.
Again, so we have the different items in a set is called the elements of that set. But let's step back a bit and tell you something about a set. Because we just don't go around and just say a set, a set, a set. We give them a name, all right? So how do we give that name? We use a capital letter. And so, for example, if I was going to be talking, I would say the set A, and you would see a capital A, and we have some lovely little brackets like this, okay? That is what we enclose them in. So the house for that set looks like this. So every time you see that notation, you know right away you're dealing in terms of the topic for sets. These are associated with it. So I can say set A would be equal to, and I can give 2, 4, 6, and 8, all right? And that is my set. Okay, now, these members, our 2, our 4, our 6, and our 8, these are what we would call, really, if you're talking like human beings and personifying them, these would be the children for this set. So, and instead of calling them, so instead in human beings, we refer to them as children, but in our sets, we call them elements. All right? So the items in the set, we call elements. For human beings, we call them our children. All right? So don't tell me you don't know that part of it, okay? So the elements then refers to the items in the set. The number of elements, again, we have a specific way and a notation for that. Here we would have been writing, if we want to talk or to ask for the number of elements in a set, it's our little n with our curly, with our open bracket, and the A would be inside like that. And as long as you see that, oh, we don't even have to have a bracket at times. It just can be N, yes, you do have a bracket, NA, and it's equal to. All we're doing, we're just counting and saying how many things we have. So here, I would have been saying it's 1, 2, 3, 4. And then so the answer here would be equal to 4. Not surrounded in any bracket, not surrounded in any set notation, just the number 4 on its own. All right? So we don't get confused as if they were asking us to list the number of items in a set. If they were asking us to do that, we'd be using curly brackets. If they ask us for the number of items in a set of items, it's just equal to 4. All right? So those are the first two things we have to know. We give them a name. If it's the name we're talking about, it is a capital letter. Then the notation that is used, our curly brackets, and sometimes, so the curly bracket, I will say, you can use it by just saying, as if you're doing a back to front question mark, and then turning it here and doing a back to front S. Okay, so if you practice that, you will get it. It doesn't come easily at first, but if you practice, you will get it. Here, on the other side, you'll just be looking question mark and a back to front S again, and you will get it. So that is our curly bracket for the set notation. The elements referred for the set is comparable to what we'll be calling somebody's children. So the members in that set is called the elements, okay? If we want to know how many, all we do, we just count. You'd be saying there are 1, 2, 3, 4 elements in set A. So that is how we get the number of elements in set A. After that, we can still now addressing certain things and giving them names. So we can talk about finite set or infinite set. Now, in terms of our finite set, so